So looking at production possibility frontiers, or sometimes called production possibility curves now, and this is an important part of the course because we can firstly illustrate some of the concepts that we've looked at in previous videos and some of the concepts that will come up in macroeconomics, but we can also, it's also a very typical part that comes up in the multiple choice questions. So there's some easy marks to be gained here if you understand what they show. So the definition of a PPF or PPC is a curve that shows the various combinations of two products that can be produced when all available factors of production, remember those resources, are fully and efficiently used. So the PPF or the PPC is shown here, and this curved shape here is representing the maximum that can be produced of two different products, and this Y and this X are representing two different products. Now they could be anything, it could be apples or bananas, not that they probably grow in the same kind of places, but it can be absolutely everything or anything. And it's lots of my students, when I first introduce this to them, they all say it's a little bit unrealistic because most businesses don't just produce two items, or most economies don't just produce two items. But we can adapt it slightly to make it a little bit more realistic, and those are the types of diagrams that we'll be using when we're looking at more macro issues. So if we thought of Y as capital goods, so the production of things like machines that are going to make other machines that are used in production, machines that make goods and services, not necessarily machines that make other machines, but we have X as well, could be thought of as consumer goods as well, and that makes it a little bit more realistic. But the reason why they're important is, and these are the specification objectives up here, the reason they're important is because we can show all of these different concepts on them. So I'll just go through these to show you how you can use PPFs to demonstrate them. So resource allocation. Here we have point A on the curve, and we have YA, we have a quantity of Y that we're able to produce, and we have a quantity of X that we're able to produce. Here we have point B, and this is a different resource allocation. We would be putting different quantities of resources in. We can see here that we're producing far less of Y, and we're producing far more of X. So each point that's either on the curve or within the curve, or I'll talk a little bit more about point D later, but any point here that's on this diagram represents a different resource allocation, a different allocation of these factors of production in terms of their quantities. So we've done that one. Okay, opportunity cost then. Now to show opportunity cost, we have to show a movement from one to another, or this is the simplest way to do it if you have a movement. So if we imagine that we started off at A, where we were producing YA and XA, and then we decided for some reason, whatever that was, that we were going to produce B. And so we were going to produce more of X, so this is what we're gaining. But to get to that area, unfortunately, we have to give up some of the production of Y. So here we can show opportunity cost. I'll change the colour on here. This space between YA and YB is the opportunity cost. This is what we've had to give up, the benefit we've given up of this quantity of Y to be able to get more of X. So the exact definition, the exact equation would be YA minus YB for that one. Okay, so we've got opportunity cost on there, and that opportunity cost is also this concept of trade-offs as well. So to get more of X, we've had to sacrifice some of Y there. And if we were going to move the other way, I'll get another colour actually to show this. If we were going to move the other way from B to A, we'd find that we'd get more of Y, but we'd have to give up some of X. So X would then be our opportunity cost, XB minus XA. That would be the equation for that one. Okay, and we're just going to move to a clean one because that was getting a bit complicated there. So unemployment of economic resources. So this is going to be important for microeconomics as we're studying this now, but it's also going to be important for macroeconomics as well, because we know that sometimes when we're looking at the macroeconomy, there is unemployment, and we look at unemployment of labour specifically as well. So point C shows unemployment of some of these economic resources, because we could oops, not a very straight line there, it's hard to do it on the computer, we could, this would be YC, produce more of both Y and more of both X. Even if we move to a position here, say that was F, I'm going to call it F because we've already got a D, we wouldn't technically be producing any more of Y, but we'd definitely be producing more of X there. If we move to this position here, I'm going to call it G, we wouldn't be producing more of X, but we'd be getting more of Y. So it doesn't matter what the combination would be. It's just that any point within this line is not using all of the resources to be able to produce the maximum possible output. So to produce the maximum possible output, you have to be operating somewhere on the line. So anywhere on the line would be what we call productively efficient, and I'll come back to that in a few slides' time. So I'll just clean that off again to make it a little bit clearer. We've also got point D here. Now, unfortunately, given the current state of technology and the amount of resources that we have, we cannot achieve this point D here. Certainly in microeconomics, we say we can't achieve that. In macroeconomics, when you get onto your ADAS diagrams, this point could be where we've got a positive output gap, but we know in macroeconomics that would only be sustained in the short run. But if we have economic growth of our economy, and really this PPF or PPC can represent, oh, very squiggly line there, sorry about that. As I was saying, this PPF or PPC can represent the long run aggregate supply when we're looking at macroeconomics. If we have growth, maybe we've got technological advancement, or maybe we've found for some reason, or we've come across some additional factors of production, maybe some oil or natural resources that we didn't know we have somewhere, we might be able to push this boundary, this frontier out, and then D would become achievable again. If we move from C to, it could be A or it could be B, we're moving from a point where we've got unemployment of economic resources to a point where we're more efficient. This would be a type of growth as well. This is you moving in the macro economy from a point of a negative output gap to the long run equilibrium there. So we would in macroeconomics see an increase in real GDP, which is what growth is, what economic growth is, but it's not an increase in the productive potential of the economy. This line has to move out to be an increase in the productive potential of the economy, because we've got kind of two really forms of economic growth. We can be looking at, well, what's the maximum an economy can produce, which is your long run AS, this PPF, and then what we're actually producing. So anywhere moving from within this curve to on the curve, or even if it's just closer to the curve, that would represent growth as well. So it's not a clear-cut picture with growth, in summary. That's what I'm saying. So key terms now, it's a good time to introduce this key term of productive efficiency. So this for an economy is where it's impossible to produce more of one good without producing less of another good. Very common definition that comes up in multiple choice questions, so make sure you know that. When we're looking at it for a firm, which we look at later on in the course, it's where production takes place at the lowest average cost. So anywhere on this curve is productively efficient. You know, some of my students get a little bit confused sometimes. In the past, they've said, well, this is more productively efficient, these points are more productively efficient than this point, because you get a mix. Productive efficiency is not making a judgment about which would be the better allocation of goods and services. All productive efficiency is looking at how you use your resources and looking at the most productive use of those resources. So it literally is anywhere on the curve is productively efficient. It doesn't matter where it was. It can be at the extremes. That's fine. We've got another definition as well, which is allocative efficiency. So this is where the available economic resources are used to produce the combination of goods and services that best match people's tastes and preferences. Bit of a mouthful there. We learn in A2 that it's where price equals marginal cost. It's basically really just this concept that we are getting the right products to the right consumers. So this one's a little bit more complicated. So we have to make, well, we know that to satisfy as many people as possible with allocative efficiency, we would believe, it would be logical to think that the greater the amount of production is better, because then we'll be able to satisfy more needs and wants. So we know that the maximum possible output of both combinations takes place on this frontier. Oh, bit of a wiggly line there again, sorry about that. Seems to be a problem when I get down to this point. So we know the point of allocative efficiency will take place somewhere on that curve, but here's the thing with this one. We don't know at what point it will be at, okay? That's down to preferences, and that's something that you would look at with something called indifference curves, and this is something that you'd study at university, so it's not part of the A-level course, but the thing that you need to know is that the point of allocative efficiency occurs somewhere on this production possibility frontier, somewhere on it. I don't know where. You would have to get the preferences of this economy or this firm or these consumers, but it would definitely occur somewhere on the curve, because that's where the maximum output occurs, and that's where we can satisfy the maximum amount of people. So here are a few past paper questions, and these can be quite difficult. I've picked out two of the most difficult past paper questions. So I'll go on to this one first, and this is looking at the opportunity cost in terms of producing one more car in terms of vans. So what I want to look at is both of these points. So I need to set up my curves there. So this is car Y, and this is van Y, and at X, this is van X, and this is car X. Okay, so if we produce one more car, okay, I'm going to do it there. I'm going to imagine that that's one more car, and I need to get the same kind of height on this one, so I imagine that that's one more car there. There we go. Okay, so produce one more car X, you actually have to give up more vans to do it at this point X than you do here. You're giving up fewer vans to produce one more car at that point. So this is a common question that comes up, and you'll see the answer there, and that's how to do it. You have to get your pencil out and draw some lines on and kind of work it out. But the reason for this is at the extremes we get increasing opportunity cost. So the real reason, going into a lot of detail behind this, is that, you know, if you want to produce more cars than and reduce the production of vans at a point like here, what you'll do is you'll move the resources that are most flexible first. So your labour, that's going to be most flexible and a kind of multi-skilled, and your machinery as well, that can kind of produce both of them. As you get to the extremes, it's harder. You've got you'll have to change your more inflexible factors of production to produce cars from producing vans, and they might be very specific toolery, it might be very specifically trained people, and it's hard to get them producing cars other than vans. So what we get is this, what we call increasing opportunity costs at the extremes here. So if we had constant opportunity costs, what it would look like is a straight line, but you see actually that we're losing out on kind of maximum production because of the difficulty of switching the factors of production between the two options for production. And if we go back to this one's, I think, a slightly harder question. So we're looking at the opportunity cost of producing, in this case it's cars, more cars in terms of bicycles that you'd have to give up. So similar way of doing it. So I'll look at, I'm just going to pick one point, and this is the point of, I'm going to call it C1. And for country X, if they produce C1, they can make this one, I'm going to call it BX1 so I don't get confused here. And then for country Y, this is BY1. And if we produce one more car, so we go to that point, C2, we can see that we've had to give up a bit of a wiggly line there, BX2, and we can see that it was going to be a bigger gap. Oh, I'm having problems with my mouse today. You can see that it's a bigger gap there though. So the opportunity cost is greater for country Y. They have to give up more bicycles to produce one extra car there. So that's how you answer those questions. Get your pencil out and start drawing onto those diagrams to make it visually easier for yourself to see.